Hello everyone, my name is V. Soumyasri. I'm from CSIT. Today I'm here to explain about an efficient algorithm for frequent pattern mining based on privacy preserving from the course Data Mining and Knowledge Discovery. Introduction to frequent pattern mining. Definition. Frequent pattern mining involves finding recurring patterns, associations, or structures within a dataset. Examples include frequent item sets, subsequences, and subgraphs. Importance of the introduction to frequent pattern mining is that it is crucial for discovering hidden relationships in large datasets, helps in various applications like market basket analysis to understand the customer buying behavior. Applications of frequent pattern mining, market basket analysis. Retailers use it to identify products frequently bought together. For example, if customers often buy bread and butter together, placing them nearby can increase the sales. This is known from the frequent pattern mining. Web usage mining tracks and analyzes user navigation patterns on websites, helps in optimizing website design and improving user experience. Bioinformatics identifies patterns in biological data like DNA sequences. For example, finding common genetic sequences associated with the diseases. Privacy concerns in data mining. Privacy issues. Data mining can reveal sensitive information about individuals. For example, mining healthcare data could expose patient identities and the medical conditions of the patients. Need for privacy. Essential to comply with laws and regulations like GDPR, maintains user trust and prevents misuse of the personal data by using the laws and regulations like GDPR. Overview of privacy preserving data mining. Privacy preserving data mining, in short form PPDM. Privacy preserving data mining refers to the techniques designed to perform data mining tasks while ensuring that sensitive information about individuals is not disclosed. The goals involved in it are to extract useful and accurate patterns from datasets without compromising the privacy of the individuals. We have to extract the patterns and accurate useful patterns from the datasets, but we have to not compromise in the point of privacy of individuals. We have to preserve the privacy of the individuals. Achieving a balance between data utility, usefulness, and privacy protection. These both are the goals that are involved in the privacy preserving data mining. Approaches to privacy preservation. Anonymization. Process of removing personally identifiable information from the datasets. Techniques include k-anonymity, ensuring that each individual is indistinguishable from the at least k minus one others, and one diversity, ensuring diversity in sensitive attributes. Data perturbation involves adding noise to data to prevent exact pattern reconstruction. We will be adding noise to the data to prevent from extracting the exact pattern reconstruction. Methods include adding a random noise data swapping and synthetic data generation. Cryptographic methods use of cryptographic techniques to perform computations on encrypted data. And the examples include homographic encryption, secure multi-party computation, and differential privacy comparison. Anonymization is straightforward but can reduce data utility. Perturbation maintains data utility but can be complex to implement and manage. Cryptographic methods offer strong privacy but are computationally intensive and may be slow. Efficient algorithms we will be using in privacy preserving data mining. Efficiency goals are to minimize the computational complexity and resource consumptions that are time and memory. Ensure that the data mining process is scalable to handle large data sets. Challenges. The challenges involved in PPDM are balancing the trade off between the privacy and the utility, ensuring that the privacy preserving techniques do not significantly degrade the quality of discovered patterns. The algorithm introduction. Algorithm name is Privacy Preserving Frequent Pattern Mining Algorithm, PPFPMA. The objective of PPFPMA is that it should efficiently mine frequent patterns while ensuring the data privacy, maintain high accuracy and utility of the discovered patterns despite privacy interventions. Algorithms is nothing but a step by step process. The first step in this PPFPMA is the data pre-processing. Data pre-processing involves data cleaning. Data cleaning means removing duplicates, handling missing values, and normalize data formats. Step 1, data pre-processing, data cleaning, removing the duplicates, handle missing values, and normalize the data formats. Data anonymization. Apply techniques such as k-anonymity or one diversity to anonymize the data. Example, removing direct identifiers like names, social security numbers, and masking quasi identifiers like birth dates and zip codes. Step 2 is that pattern generation. Use FP growth algorithm, an efficient method to identify frequent patterns without the candidate generation. Integrity of privacy measures. Introduce controlled noise or randomization during pattern generation to ensure privacy. For example, add random noise to frequency counts to obscure exact pattern occurrence. Part 2 of the algorithm, the step 3 includes pattern selection. Threshold based filtering. Use a minimum support threshold value to filter out less frequent patterns. Heuristic methods. Apply heuristic rules to select the most relevant patterns while considering privacy constraints. For example, patterns that occur in at least heuristic methods apply heuristic rules to select the most relevant patterns while considering the privacy constraints. Example, patterns that occur in at least 1% of transactions are considered significant. Step 4, privacy preservation techniques. Differential privacy, add control noise to data or query results to provide privacy guarantees. Evaluation, continuously evaluate the impact of privacy preserving techniques on pattern utility and adjust the parameters to optimize the balance. Example, apply a Laplace mechanism to add noise proportional to the sensitivity of the query request. Example scenario, dataset, retail transaction data consisting of customer purchases over a year. Example, each transaction includes a list of items bought by a customer at a grocery store. Process. Step-by-step application of PPFP-MA to identify the frequent item sets. Identifying that milk and bread are frequently bought together while preserving customer privacy. through anonymization and noise addition. Performance metrics are accuracy, measure the correctness of the identified frequent patterns, metrics, precision, recall, and F1 score. Example is compare identified frequent patterns against known patterns in a benchmark dataset. Runtime, time taken by the algorithm to compare the mining process. Metrics, total execution time, time per transaction, time per pattern generation. Example is that compare runtime of PPFPMA with additional FP growth on the same dataset. Memory usage, amount of memory consumed during the algorithm execution. The metrics are peak memory usage, average memory usage. Example, memory consumption measurement of PPFPMA and compare with other privacy preserving methods. Privacy metrics, degree of privacy achieved quantified by metrics such as k-anonymity level, differential privacy, Clipson, evaluate the effectiveness of noise addition in preserving privacy while maintaining the data utility. Experimental results, setup, description of the experimental environment, hardware specifications of the computer system used for the experiment, for example, processor and RAM, software, tools and libraries used for the implementation, for example, Python, are data mining libraries. Data sets, types of data sets used for testing the algorithm. Examples, retail transaction data, weblog data, healthcare records, size, number of transactions, items, and attributes in each data. Experimental results, runtime comparison, graph showing execution type of PPFPMA versus traditional FP growth, accuracy of patterns, table displaying precision, recall, and F1 score of patterns identified by PPFPMA with different noise levels, memory usage, bar chart comparing memory usage of PPFPMA with other privacy preserving algorithms. Analysis. Discussion of results highlighting the efficiency and effectiveness of PPFPMA, impact of privacy measures, analyze how privacy preserving techniques affect the accuracy and utility of the patterns. Example, detailed analysis of how differential pattern privacy noise affects the identification of frequent item sets. Comparative analysis, comparison, compare PPFPMA with other privacy preserving data mining methods. The metrics are accuracy, runtime, memory usage, degree of privacy. Methods, compare with methods like a priori with the differential privacy, anonymized FP growth. Advantages, highlight the strengths of PPFPMA in terms of efficiency and privacy preservation. Example, PPFPMA achieves better runtime and memory usage while maintaining comparable accuracy and privacy levels. Case study, real-world application of PPFPMA in a specific domain. Example, healthcare data analysis to identify common disease co-occurrences while preserving patient privacy. Outcomes, benefits observed from using PPFPMA such as improved privacy and insightful pattern discovery. Example, successful identification of disease patterns without compromising patient confidentiality, leading to better healthcare insights and policy decisions. Challenges and limitations. handling very large data sets with millions of transactions, ensure high utility of patterns despite privacy preserving measures. Examples dealing with the trade off between noise limitations, potential limitations of the algorithm, such as scalability issues and sensitivity to parameter settings. Example, high noise levels may lead to loss of important patterns, while low noise levels may compromise the privacy. Future work improvements can be done, potential enhancements in algorithm efficiency and privacy techniques. Example, developing more sophisticated noise addition techniques to better balance privacy and utility. Research directions, areas for future research such as combining PPFPMA with other machine learning techniques. Example, integrating PPFPMA with deep learning models to enhance pattern discovery in complex datasets. Conclusion, recap of the key points covered in this presentation. Overview of PPFPMA, its efficiency, privacy preserving techniques, and experimental results. Final thoughts emphasize the importance of balancing efficiency and privacy in data mining. Example, the need for continuous research and development to improve privacy preserving data mining methods. Thank you. Thank you for giving this opportunity.